Good afternoon, and I would like to thank you for giving me the opportunity to do this presentation. So, usually when they teach you, train you how to do good presentation, they start telling you, never start with apologizing and saying sorry, something like that. So I'm going to break that rule and I'm going to say sorry. I forgot to leave my Croatian accent at home. So sorry about that. So my topic today is about predictive maintenance and how to effectively run predictive maintenance. We can say that we are proud to say that we have successful predictive maintenance. And I'm going to talk a little bit about that and happy to answer some questions later. So company I work is, main product is the pulp and power. Lately, we make more money on the power than on the pulp. Just market is like that. We are located in British Columbia, just 600 kilometers east of Vancouver. And we are part of Mercer International. Mercer International owns 3 pulp mills, us and 2 in Germany. What is the benefit that we, to those mills in Germany and us, we share our knowledge and experience very close to each other, visiting each other, has predictive maintenance sessions, and quite a bit benefit for doing that. So, why is that predictive maintenance, what we did about that? We basically identified that predictive maintenance, traditional way how it used to work, is very challenging, and how to actually create effective predictive maintenance system. So, my second was people. What Paula mentioned about 50-60% people retired. We are similar. We are 50%, and one hope is that our pension plans are terrible, so it might be a little bit longer, but it's not good, definitely. So we're going to lose our 50% of our workforce in the next 6-7 years. Process. Pushing more for less. So basically, process, we continuously tuning our processes. I think more than 70% of our equipment is the variable speed drives. So basically, we're running those machines, tuning them continuously. So that doesn't make easy job for predictive maintenance. Second thing, we can collect data, but who's going to look at all those data? Also, we mentioned how to do analysis. We know that we basically have a certification program, and we try to be one of the best. We use technical associates. I basically train my guys, and after I send them out for certifications. And we do everything to technical associates. We think that they are one of the best. I personally have from Vibration Institute in US many years ago. So when I had a chance to meet other people, it's very interesting, guys, that you can see level 3 vibration analyst, but basically when you look at their database, how is point set up, it's quite a bit challenging, what level 3 means for different certification houses. It's very, very challenging. So also when guys are making calls, change the pump, basically we change the pump which failed and put same pump back. So we try to put effort on the root cause analysis and how to effectively, improve, but it's very, very hard traditional way to, no means to improve, just basically replace it, we say that. So what is our definition of classical predictive maintenance? Basically, you had route-based data collecting of frequency, whatever you decide, certain critical equipment more often, non-critical less, but this is how we collect the data. Traditional system collects data before startup, shutdowns, new installation, follow-up. This is how we collect data. But troubleshooting how bad is bad, how long it will last. Usually you bring a vibration guy and and say, okay, how long are we going to last? We have a shutdown next month. Are we going to make it till that time? So that guy is really challenge position, when you say how long last. So it's huge responsibility to say it will last or it won't last. First thing, the vibration analyst knows that when they open that machine, they're going to find out is that call was good or not good. Same thing, if it failed before that, they're going to say, oh, how come you didn't make call earlier? So I already mentioned quality of databases. I was involved in probably 5-6 different databases reviewing and lots of challenges. It's hard to find standard, basically, how to set up properly. There is the common recommendations from those certification houses, but in reality, when you come, especially in low-speed applications, when you're having how to troubleshoot 4 RPM piece of equipment, it's quite a challenge to set up those points. And this is traditional, classical predictive maintenance, and this is one of our main problems at the bottom. When we found the problem, what we do about that? I just got called, guys, when I'm here in the conference, we have set up, I'm going to show you my cell phone, basically email notification about alarm. And we went down yesterday. And when I communicate with my guys what's happened, we entered work request to change one role on primary screen 10 days ago. Work order went on planning, it's scheduling, and basically didn't make it. So mill went down. So we're going to have, when I come back, a review, about how to prioritize those work orders properly and effectively. So we found the problem, we did everything, but still failed. So from predictive maintenance side, we are clean, we made the call, too bad. But in reality, this is our problem together. So we have to go back and find out how to more effectively implement our suggestions. So what we did, we implemented aptitude decision support system. This is SKF product, and this is my pleasure second project what I work, second implementation. I started probably in 2002, so this is quite a bit experience in that. So we call that, in our place, this is not optional. This is a must. And I'm going to show you why is that a must. So this is knowledge-based system what SKF developed. Basically, if you think about equipment, electromotor is electromotor, doesn't matter which industry you're talking about. Electromotor has common failure modes, faults, symptoms of those faults. So SKF put some knowledge how to put those models for electromotor, so typical piece of equipment, electromotor, pump, gearbox, fan. So this is how we started. So we bought that system and we started implementing. So basically what I found, there is the knowledge existing on the market which can support our diagnostics. So we called it automated diagnostic system. SKF tried to avoid term expert system, but this is something like that because people are usually afraid if you call the expert system, you're going to replace people. No, it will never replace the people. You still need good vibration guy, and you still need good people to run that program. This is just big help, and I'm going to show you why. So how it works right now? What data coming in that system? So basically, ODR stands for operator-driven reliability. So we would like to have operator involved in inspections, not only maintenance. There is lots of operation inspections. They are not only maintenance related. We want those guys to put their input. And how to put input if you have different operator, different train, standardized, how to communicate those things. So we implementing, and we're still in the process of implementation, mill-wide operator-driven reliability. Process data. So we saw here, everybody's talking about DCS, how to communicate, but this is just too much data. We don't have enough people to look at every spectrum, every waveform, every trend on DCS, every alarm. So basically, We also have route-based data collection, and we have online systems. So we found out that doesn't matter how good we are on the floor, we need continuous monitoring systems. So we have basically 6 permanent, and we have, God bless, wireless technology, 50 wireless units, continuously monitoring, and we would like to expand that more. We build wireless meshing network that wireless unit we can move from one piece of equipment to another one, and it's continuously collecting data and sending. And we have decision support with continuously doing analysis. So diagnostics through decision support. Basically, when guy collects the data and he puts his instrument in docking stations, he goes to lunch. When he comes from lunch, diagnostics are done. When I used to have those traditional predictive maintenance, I would collect data 2 days. I was consultant. I would come in the mill, collect data 2 days, 3 days. I would come back and do analysis, sitting. Spent another 2-3 days. This part is basically continuously doing diagnostics. Also, what is important, that system doesn't tells you it's an alarm. Basically tells you that you have alarm, tells you what's the recommended action, and what is reference for that suggestion. So this is very important part. So we have basically about rough estimate, 250,000 different readings a day. So this is from DCS, route-based data, continuous monitoring system, everything coming on our server, and the decision support do diagnostics. How do we communicate those things? Of course, PC networks, but lately, smartphones, iPads. I'm here, guys, I just am talking to you, and I got my email and telling me right now that I have pumped that electromoron alarm. And I'm not only one who is getting that alarm. We have basically set up individually who is getting alarm from what. All alarms coming to me, my position is reliability superintendent, 2 reliability engineers, vibration guys, and area of operation, whoever is in that area. So superintendent or fiber line, or how we have defined those, doesn't get from utilities. We try to select those alarms. So follow-ups. We right now are working on implementation with CMMS system, how to, basically we just switched to new CMM instance, so we have to build new interface. But what is beauty that when we get recommended action, we basically trigger a work request, and all fields are already filled up, and you can see what is the reference, and you do your adjustments, review, and send work request for review. Did we miss anything? Yes. We guys, anytime we still have some issues, and what we do basically by learning how those models work, how to tune those alarms, daily basis, we learn. And I have to tell you that basically in my 10 years, I lost 6 vibration guys. 2 died, 2 of them died, 2 retired, and 2 just left our company. All that knowledge and training would be lost without decision support. We still have the decision support, and I basically had new guy has to train them how to use decision support, and he's going to quick learn how that system works and how to do diagnostics. So this is, by challenging, tuning those models, it's steep learning curve. So what's the vision of the predictive maintenance in this century? To know any time status of your equipment. This is the main, you have to know. I'm talking to you, and basically when I finish, I'm going to look at those 2-3 emails, and I'm going to have to respond to them to see how the guys are doing that. Second thing is engagement. So I'm here, guys, in that conference, and I'm still engaged with my mill. All my guys are having the same thing as I have, small iPhone and iPad. They can go anytime and be notified. And we call that who is main guy on the call, who is responding. And of course, they are not expecting that I'm going to be main guy to making call when they know that I'm on conference. But I'm going to look at, and I come back and send some of my suggestions. Also, I mentioned that operator-driven reliability. It's huge. So implementing continuous monitoring systems has huge benefit, but we're still missing that guy who's going to walk on the floor and see that leak, see that crack, unusual noise. So this is why we need somebody still walk around, and that's operator right now doing. So there's huge benefits about doing that. Also, on the bottom, I mentioned about typical models. We have right now about 100 models already built in, tuned. So each industry has some specifics, like in pulp, rolls are very typical. So each alarm is, this is big one. Each alarm is supported with reference recommendations. So you are not alone to make the call. So when you're reviewing that recommendations, and when you make the call to do some big job, basically you come in and say, look guys, I have my decision support system I review is making that call, and I agree that, and I suggest to do that action. So this is big one. Event log. Event log is tracking all activity on that decision support. From time when you install that first on your database, each alarm, if you tune every alarm, you do adjust a little bit up and down, tune that, it tells you who did what. So you can export that file and you can find out from the first day who did what. And also what is benefit, when we do root cause analysis, we had cases when the guy's saying, no, that's not lubrication problem. And you run to your event log and you say, look guys, we have on that piece of equipment statistically 40% of our alarms are triggered from lubrication. So let's talk about lubrication, how that can affect that. So it's big tool for us. We use that when you're doing root cause analysis. So what's the benefit of our program? Right now, we know condition of our critical equipment at any time. We basically, officially on our program has 856 pieces of equipment, but there is rest what we don't monitor detail, but we call that C priority. So on those 856 in 2012, we have zero failures. So we're proud to say that we didn't have unpredictable failure in our we predicted certain failures, and we had, but we predict them. We know that it's going to happen. We just choose to do something or not to do. So that was our choice. We made calls, guys, big calls. We installed new turbine, $55 million turbine in 2010. 8 months later, we're calling, changing bearing under warranty. Shin Nippon didn't want to hear about that. We fought with them and we basically said, okay, guys, we're opening that. If nothing is wrong with that bearing, we pay for that. If it is, you paying. That's right, it was a good call. But without decision support, it would be hard to make that call. Guess what? We replaced 3 more bearings. We're still under warranty, extended warranty, and pushing Shin Nippon to work with us why we have failures. And basically, decision support is telling us what's the problem, why we're losing bearings. We have aerated oil and lube system, and we can't solve the problem with our supplier, why we're having that. Startups. Huge. Guys, I'm going to show you a couple of slides. You basically going on a shutdown mode, and you plan your jobs, what you're going to do. And guess what? During the shutting down, you damage piece of equipment. You don't know about that. You want to start up? Problem. So with continuous monitoring system, we managed to catch quite a few of them. Same thing on the startup. We start up, we screw up things. It's so. Lesson learned. Automated diagnostic system is way. We wouldn't, if you ask in my mill, anybody would do a different way. Forget it. This is only one way. And we know that we have 250,000, we're going to go for more. We have to go more with operator-driven reliability. Those guys on the floor, we have basically weekly, right now, about 35 follow-ups triggered from ODR. And we have system communicator who is responding for those operator initiate certain things. who's responding, and we make sure that that operator get back information what we did about that. So we're really making sure that those guys engaged, they know that it was good call. Engagement. So having operator direct communicate guys, having us outside of the work, this is really engagement. And what is most important, power of knowledge we own. SKF built that, or the decision support, but we own that. We know probably about that decision support more than SKF now, believe me, because we learned that, and we practical way, and we communicate, send them feedback, they know about what we're doing, how we're tuning, and this is why they invite me, here to speak of that problem. So, challenge for you question, do you think you have good predictive maintenance? I thought 8 years ago that I have best predictive maintenance. Guess what, I learned that how that wasn't good. Probably in the next 10 years we're going to learn more how to improve even better. But we are convinced that this is the right way to do. So typical hierarchy, how it looks like. So basically you have model built for electromotor, for belt drive, for gearbox, for feeder, and performance of that. So total performance of how that piece of equipment performing. So here's the case, guys. So we got call from ODR, alarm. So we analyzed it's lubrication related, but also has bearing failure and is 3rd to 4th stage of bearing failure. So it's going to make it, but it's close. So we greased, babysit, and we monitor how much grease we put on. We have device to do that. Look at that, again goes. So we have 5 events of greasings in 3 days. So we finally get opportunity to shut it down on you can see one more time we went shut down, but we didn't have chance to replace that. We started up, we get high alarm, and finally we replaced that piece of equipment. So without technology, who's going to collect all that data? Who's going to do analysis and tell you what to do about that? It's almost impossible, I can tell you. So this is the one simple case. Second one is operator. You come in the morning and you read your report and says, we just plugged our EO press on pre-bleach. What did you do? I look at my analyst, my email, basic notification, get alarm, look at on the startup, bang. So we have to do something about that. We did something and we're managing through. It's still on alarm, but we're managing that alarm and tuning to the next opportunity because require 2-day shutdown. So we're trying to manage that for next opportunity to avoid shutdown. Another thing what is important, we basically configured the system that we're building overall trend to do, but you can look at that, how much data we have last 3 days. So when we do analysis, you can see this small jump at the end, and we went down and started up. We damaged that. But we have lots of data to do analysis. There is no route-based data collection which can afford it. We are talking here about 600-700 readings. This is huge amount of data. But we also build scheduling system that do auto-archiving. Our database is not growing up. So I can show you more details if somebody wants. Oops. So also I didn't mention, we develop based on condition monitoring, ODR, and we call that condition-based greasing. So that can be totally separate topic. I promised that we're going to write some article and share it with you guys, and Noria came to me. So we will do that one day. John and I asked him for help to how to put those things together. But we found successful way how to do it. And I really encourage you guys to ask SKF what is decision support and how they promote that. Thank you, and I hope so I have some questions.